previous classes of moment of inertia, we have solved the problems in which we have determined the principal moment of inertia, that is the moment of inertia of the figure about centroidal axis, or about the axis passing through their centroid. So that moment of inertia is also known as principal moment of inertia. Now here in this figure, we have to determine the moment of inertia about a predefined line or predefined axis, that this is a problem. Find the moment of inertia about given x-axis for the shaded area shown. So given x-axis is this is given x-axis. About this axis, we have to determine the moment of inertia of this shaded area. So in this type of problem, we do not require to find out the centroid of the figure, because we do not need the centroidal axis. So in this figure, we do not require to find out the centroid of the figure. In this, we can directly find out the moment of inertia of this composite figure about this x-axis. So this figure is made up of by three figures. One is, this is right angle triangle. This one is right angle triangle. For this triangle, the base of the triangle is 5 into 2. So it is 10 centimeter. The base of the triangle is equal to the diameter of this semicircle. So diameter is 10 centimeter. So the base of the triangle is 10 centimeter. And the height of the triangle is 15 centimeter. And this semicircle, which is added to this triangle, this semicircle is of radius 5 centimeter. And this whole circle is deducted from this figure, which is of 2 centimeter radius. So now we find out the moment of inertia, this triangle about this x-axis, this baseline, about this baseline for this triangle, and about this diametral axis for this semicircle, and about this diametral axis for this whole circle. So now first part is triangle, second is semicircle, and this circle is third. So now Ix is equal to Ix1 plus Ix2 minus Ix3. Or when we derive the formulas from first principle by integration method, there we have determined the moment of inertia of a triangle about its baseline, which was equal to bh³ upon 12. bh³ upon 12. For centroidal axis, it was bh³ upon 36, and about baseline, it was bh³ upon 12. Plus for this semicircle, the moment of inertia of this semicircle about this x-axis will be equal to pi r to the power 4 upon 8 for this semicircle. And for this whole circle, about its diametral axis is pi r to the power 4 upon 4. This is for whole circle, and this is for semicircle, and this is for triangle about this x-axis. So now bh³ upon 36. So base is 10 into 15 ka cube divided by 12 plus pi into r for semicircle is 5, r to the power 4 upon 8 minus pi, r for circle is 2, so into 2 to the power 4 upon 4. Now on solving, this is equal to 10 into 15 to the power cube divided by 12. So this is equal to 2812.5, 2812.5 plus this pi into 5 to the power 4 divided by 8. This is equal to 245.43, and for this is equal to pi into 2 to the power 4 divided by 4. So this is equal to 12.57. So it is minus 12.57. So on heading up, this is 2812.5 plus 245.43 minus 12.57. So this is equal to 3045.36. 3045.36. So it is centimeter to the power 4. So this is a very easy question and very small. So in this, we can directly find the predefined axis. Directly find out the moment of inertia of individual figures, and then by their plus minus sign, we can find out the values. Thank you very much. So this is another problem. Find Ix and Iy about given axes for shaded area shown. So this is a problem. For this, we have to find out the moment of inertia of this shaded area about this x-axis and this y-axis. That is, we have to find the moment of inertia about this x-axis and this y-axis, not about the centroidal axis. So in this problem, we also do not require to find the centroid. We can directly find out the value of moment of inertia about x-axis and y-axis. So for this, we have divided this figure like this, like this. So this is a triangle, this is a rectangle, and a semicircle is deducted. So this is first part, this is second part, and this is third part. So in this case, we have to find out the value Ix and Iy. So now for Ix. So for Ix, this will be equal to Ix1 plus Ix2 minus Ix3. So Ix1 for this for this triangle. So for this triangle, about its base, So for this triangle, about its base is BH cube upon 12, and this will be equal to base is 15 minus this 10 is equal to 5, and height is 15. So 5 into 15 ka cube divided by 12. So about the baseline x-axis. Now Ix2 for rectangle. So for this rectangle, about this baseline. So for this rectangle, we have determined in earlier lecture the formula BH cube by 3 for a rectangle. About its base is BH cube by 3. So this is BH cube by 3. So this is 10 into 15 ka cube divided by 3. So this is for triangle, first one, and second one is for rectangle about this baseline. Now for this semicircle. So for this semicircle, about this baseline. So first of all, we will find the value about this line of symmetry or centroidal axis, about this centroidal axis, and then we transfer it from here to here, from here to here. So the gap is between this is 4 centimeter, equal to the radius. So now this is equal to pi into r to the power 4 upon 8 about this axis. About this axis is pi r to the power 4 upon 8 plus area pi r square by 2 into this gap whole square of this gap. So this gap is equal to r. So into 4 square into r square, area into r square. So this is the value for Ix, Ix1, Ix2 and Ix3. So now we can find out the value Ix by calculating these values. Now we determine the value of Iy. So for Iy, again it will be Iy1 plus Iy2 plus minus Iy3 for a semicircle. This will be minus because it is deducted. So Iy1, now Iy1. So we have to transfer for this rectangle. We will find the value about the centroidal axis of this rectangle. About the centroidal axis of this rectangle. Then we will transfer it to from here to here. So in this case of rectangle, we cannot transfer the moment of inertia from this line to this line, because in parallel axis theorem there should be a moment of inertia about centroidal axis also. So we have to find out for this triangle about the vertical centroidal axis. Then from that centroidal axis we will transfer it from there to here. So for this triangle, BH cube by 36 for the centroidal axis, moment of inertia about centroidal axis, BH cube plus 36 plus area 1 by 2 into B into H, and this distance ka square. So distance ka square is the distance of the centroid from here up to here. So this will be equal to 10 plus 5 by 3. From here to here it is 10 and remaining is 5 by 3 because this is 5. So this is 5 by 3. Now the base is this and height is this. For the triangle, base is this, height is this. So for this is equal to base is 15 into 5. 15 into 5 ka cube divided by 36 plus half into 5 into 15 and multiplied by this plus 5 by 3 का whole square. 10 plus 5 by 3 का whole square. This is very important. Please remember this, that the moment of inertia about the centroidal axis of the triangle, and now this moment of inertia is transferred to here. So from this centroid, the distance is 10 plus 5 by 3. So this BH cube by 36 plus 1 by 2, 5 into 15 into 10 plus 5 by 3 ka whole square. Now IY2. IY2 is for rectangle. So IY2 is for rectangle. Now about this line, we can directly find out by BH cube by 3. But here in this, the B is this and H is this. So B is 15 into 10 ka cube divided by 3. So this is for the rectangle about this line. Now for the semicircle about this line. So for semicircle about this line is directly by the formula IY3, and this will be equal to pi into r to the power 4 upon 8, or this is equal to pi into r to the power 4 upon 8. So directly by finding these values on calculating, we can find out the value of Ix and Iy. So after calculating, we will put these values on calculating. This is BH cube by 12. So this is equal to 5 into 15 ka cube. So 5 is the base and 15 this height. 5 is the base and 15 is this height. So 5 into 15 ka cube divided by 12 about the baseline for the triangle. So it is equal to this 1406.25. Now for this rectangle, so for this rectangle, BH cube by 3, and this BH cube, B is the 10 and height is 15. So this 10 into 15 ka cube divided by 3, and this is for triangle. The value is 11250 centimeter to the power 4. And for this semicircle, this is pi r की power 4 upon 8 about this centroidal axis, and this is transferred to here. So plus area pi r to the square by 2 into this square of this radius. So this will give 502.65. Now on this, adding first two and from then deducting third. So this will give 12153.6 centimeter to the power 4. And here again on solving these values, we can find, we are getting this value 5156.25 centimeter to the power 4, and from this bh cube by 3, this is equal to also centimeter to the power 4, and for this semicircle it is also centimeter to the power 4. So now on adding first two and minus third, this will be the value of Iy. So by like this we can find out the values about this x axis and about y axis. So in this case we are not requiring to find the centroids of the whole figure. We can directly find out the values about this line and this line. Okay, thank you. So this is another interesting problem. Find the moment of inertia about its baseline for the shaded area. So this is the shaded area given, and this is the baseline. So about this baseline we have to find out the moment of inertia about this baseline. So this is a rectangle, and from this rectangle a semicircle is deducted. A semicircle is cut down. So for this we have to find out the moment of inertia about this x line. So now this is very important problem and asked so many times in the examination. So now this Ix is equal to Ix1 minus Ix2. So this Ix1 is for rectangle. So rectangle, this side is 10 and this is 5 into 2, this is 10. So this is a rectangle or square of 10 by 10. So this is BH cube by 3 about its baseline. For a rectangle or square about its baseline, it is BH cube by 3. So this is equal to 10 into 10 ka cube divided by 3 for this Ix1. So this is equal to 10 to the power 4 divided by 3. It is equal to 3333 equal to 3333.33. This is Ix1. Now Ix2. So Ix2 for this semicircle. Ix2 for this semicircle. So for this semicircle, first we will determine the moment of inertia about its centroidal axis. About its centroidal axis, and transfer it from here to here. So centroidal axis, suppose this is the centroid of this semicircle, and this is at a distance from here, it is, this distance is 4r by 3 pi. This distance is 4r by 3 pi. So the remaining distance is 10 minus 4r by 3 pi. So we apply the parallel axis theorem between these two lines, because in parallel axis theorem, one axis should be the centroidal axis. So this is the centroidal axis, and about this centroidal axis, the moment of inertia of a semicircle is 0.11 r to the power 4, and this 0.11 r to the power 4 will be transferred to here. So it is equal to 0.11 into r to the power 4 plus area A and distance the square. So this is equal to 0.11 into 5 to the power 4. 5 is the radius, plus pi into 5 pi square divided by 2 area of the semicircle into distance. Distance is 10 minus 4r by 3 pi ka whole square. So this is the distance. Now on calculating this, we can find out the value 0.11 into r to the power 4 plus pi into r square divided by 2 into 10 minus 4 into 5, 20 divided by 3 into 5 square, and this is equal to 2505 2505.91. So now this Ix is equal to Ix1 minus Ix2. So it is equal to 333.33 minus 2505.91. So this will be equal to 3333.33. So this will be equal to 827.417. So this is a very interesting question. In this question, the moment of inertia of this semicircle about this centroidal axis, and then it will be transferred from here to here. It has been transferred from here to here. So this is the method of solving this type of question. Okay, thank you very much.